Hey everyone, Mark Price here at devslopes.com, and today we're going to talk about variables and about how computers work. Basically, if you've never programmed before, you absolutely need to take this lesson and absorb it because it is the basis and foundation of everything you're going to be doing. So go ahead and open up your Android Studio project. In fact, you should have already figured out how to create a new module. I showed you that already. And what I want you to do is either use the one that we created together or create your own, but create your new module, okay, like we've done here. And remember, you can right click and run to print it to the terminal down here, okay? So what we want to do is talk about variables and what a variable is. And then we'll talk about how computers work so you can kind of tie together the things we just talked about. So you've seen this thing here, system.out.println, and more or less this is a method or a function, and it's a function is performing something and a variable is storing something, okay? But we're not talking about functions today. So we've got this right here, this thing that says slay the beast, and this is what's called a string. In this case, it's a string literal. We're not actually storing it in a variable, we're just using it right on the spot. So what if I wanted to actually store a string? Well, there's a keyword or a class name in Java called string, and this is a variable, okay? This is a type, and we're going to say name, and we're going to say equals John, and put a semicolon at the end of the line here. Make this bigger for you. So what we've just done is we've created a variable called John, and it's a string, okay? And to show you that there's different things you can do, I can create something called int or integer, and I can call this, let's say, home runs. He's a baseball player and he has 55 home runs. And so in this case, I'm storing a number into a variable. And what a variable is a container. Okay, it's a container that holds data, but it's human readable. And what that means is you've probably heard the nerd talk at some point in time, you know, zeros and ones, right? 0, 0, 1s, you know, you see sequences like this, okay? That is language that your computer can understand, because at the very base level, everything's happening in true or false, zeros or ones, okay, more or less. And so that's not very readable, is it? Can you imagine having to write code in zeros and ones? Our brains can't process that, right? And so later on, we invented something called assembly, and there's other types of low-level languages like that, but there's a lower-level language that can actually do operations on these here, okay? And in fact, I'll just pull it up right here. I'll show you what that looks like. Just pull it over here. So we're not going to dwell on this because this can get really confusing, okay? But you know, I was talking about the zeros and ones. These aren't zeros and ones, but just for the sake of this conversation, this is what I'm talking about. So this is the machine code or the code that your machine can understand. But we as human beings, we struggle to understand that. So then we can work at a really low level here in assembly language, which is kind of a step above, okay? And I'm not going into the theory and computer science behind this. I'm just giving you a brief, you know, layman overview of this because you don't need to understand this right now. But basically, you know, we can move things, push things. You can kind of start to see the language here, but it's still very complex and overwhelming. So then we have code, right? We have human readable programming languages, and that's the whole purpose here. So maybe in the past you've thought to yourself, oh my gosh, programming's so hard. Well, actually programming is the highest level of, at least in language like Java or Swift or Objective-C, it's the highest level that is most human readable, okay? So it doesn't get much easier than this. And so what happens more or less is your code here will be compiled down into machine code, or the code that your computer can actually understand. Does that make sense? And so when we actually store or create a variable of type string and call it a name, what we're doing is we're taking memory, like that little slot of memory, or those zeros and ones that I'm just talking about, okay? And we're reserving a space in that, and we're actually storing a variable in it. We're storing a string in it. And the cool thing is the compiler does all the hard work in converting that to the zeros and the ones, so you don't have to do that. So it's very human readable. And so this is what we get to work with. So it's cool. So, you know, I've got a string named John, and he's got 55 home runs. You know, he's probably got a bank account too, right? So we can do a float, which means basically numbers with decimals, okay, floating point numbers. And we can call this, you know, bank balance equals 100.44, and we'll put the F there. It's required so we don't have an error. And then we can even print this. This print function right here actually knows how to convert numbers into strings and such. And so we can say, let's get rid of these quotes here. We can say name. So notice how I'm not typing in the word John. I'm just typing in the variable name, the name that we dropped that string into, that bucket, that holder. It's an alias, whatever you want to call it. It's holding that data for us, and we've named it. Okay, just think of it as a bucket that you've given a name and it's holding some data. That's what a variable is. So we can say name, so John, you can interpret it in your head, John, and we can say plus, because we can actually add strings together. John has, and that's just like a plus sign you might use on paper math, you know, good old high school math or whatever. Not even that, even elementary. So John has, and we can say plus home runs. So now keep in mind that's grabbing us the number because it's an int, right? So John has 55 plus home runs. And if I right click and run this, okay, if you look there at the bottom in our terminal, John has 55 home runs. So what we've done is we've grabbed one variable, which is storing the word John, the string, plus, and this is a string literal here, so we didn't store this string in a variable, we just are using it directly, instantly. So when we're done using it, it's going to go away. We won't have access to it anymore. So John has plus. Now you're like, wait, this says home runs, but this also says home runs. Well, this is the name of the variable. Okay, it's what we named it. So it's actually an integer, and it's a 55. So John has 55 plus, and then another string here called home runs. Okay, so that's the basics of variables. You're creating a name or an alias, okay, a bucket that you're putting a name on that's going to store data that you can use at a later point in time. And I just want to emphasize this a little bit further to nail it home here. I'm going to open up my Photoshop here and draw you some cool pictures. Okay, so let's talk about how computers work and then how that will translate to variables. And once you finally get this down, okay, it'll be the foundation of everything else you're doing. And sometimes it's a little bit hard to grasp at first. So if you don't get it, it's fine and it's normal. So you've got a computer, right? It looks like this. If I had my drawing pad in front of me, it would look a lot prettier. I'm just using the mouse. But here's your, well, this is really a monitor, but let's pretend this is your computer, okay? And computers have what? You know, they've got graphics cards, they've got RAM and things like that. You've probably heard those terms before. You know how your nerdy friend or your friend who thinks he's a nerd, he's like, I just upgraded my PC to DDR 256 RAM. You know, he's acting all cool and you're like, oh, whatever. Well, what is RAM? Okay, what is RAM? Let's take a look at that here. So what is RAM? Well, let's talk about that. So you know, if you've ever bought in RAM, it kind of looks like this. A little bit cooler, but you know, you've got your little black chips in there, you know, it's got little spiky things coming out. Anyway, this is actually your hardware, right? And what RAM is it's random access memory, okay? Random access memory. And you're probably wondering, if you don't know this, you know, why do we need more RAM? Why does more RAM make a computer run faster or seemingly run faster, if that's even the correct term? And here's the reason why. So let's say you're creating an application, a software application, like we're doing right now with the Java strings. Okay, let's say that we're creating an application. So here's our software application, right? You know, you've got your close button, your maximize button, whatever. And every time you write a line of code, so every time you write a line of code like this string name equals John, this is what's happening. Okay, when you run your program, let's say string, okay, string John, okay, right? That's what we did. What's happening when the compiler compiles that code? It's actually going to store that in your RAM. Okay, and your so every variable in your application and all your functions, more or less, are going to be stored in your RAM. So bam, 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 bam. So the bigger the application, the more RAM it's going to take. Do you ever wonder why when you're running on a computer and you have multiple applications going, you got Photoshop going, you got something else going, your computer starts going a little bit slower. Well, that's because you're running out of space for your RAM. All these programs are using variables, and there's other factors too, okay, but this is the big one. So all your programs, so this is Photoshop, right? I'll say PS for Photoshop, and this is our application. We're all using this RAM here, and what happens is it stores those variables in your program, uses it, and then it gets rid of them as it doesn't need them. So let's say you're on an Android app, and one screen, and because Android apps or Android devices have RAM too, you know that, right? Okay, so mobile devices also have RAM, and basically when your application stores data in it on one screen, and then you go to the next screen, well, it's like, I don't need that data anymore. So then what it does is it kicks it out. It says we don't need it anymore. It gets rid of it, cleans up the space. Okay, and so that's how programs work. And so every time you create those variables, they're being stored here in your RAM on your computer, on your device, whatever it may be, and it's reading the location there. Okay, so if we look right here, see this string name equals John. Okay, what's actually happening is it's storing it in some location here on your device, X4, 5, 6, whatever, some little memory location that's on your device. It's actually storing it in a location, and that variable name, you didn't have to actually grab a location for it. It just knows where it is. Your program knows automatically. It makes it really easy for you to work as a developer. So that is why the more RAM you have in a device, the more applications you can run at once, and the more things can happen concurrently at the same time, because those variables are being stored in there and all the operations for your application. And that's kind of how it works. So those are your variables, and you're just giving them a name, and it's storing them on your hardware and retrieving them later as needed. And on mobile devices like Android and iPhone, that's why it's so incredibly important to write very good code, and don't waste space, and don't leave variables that aren't being used, because they will use RAM. And if you have RAM being used, or memory, let's start using the term memory. If you have memory being used or being reserved that's not being used, you're wasting space and creating a bad user experience. Okay, so going back here, variables. Okay, again, it is an alias that you put data into. So again, think of a bucket you put a name on. I've got a bucket of rocks. I've got a bucket of, screws. I've got a bucket of water. Those are 3 different things that those buckets are carrying, 3 different types. And you're writing a name on each one of them. Okay, it could be name, it could be home runs, it could be whatever. And so that's what variables are. Buckets are aliases for that whole data that can be retrieved at a later point in time. So this name right here, as you can see, we used it down here. If I wanted to emphasize it even further, if I wanted to say float final balance equals bank balance minus, let's say, 50, okay? So final balance equals bank balance minus 50, and then I could actually say John has, let's say, plus final balance, John has whatever that amount's going to be, plus in his account. Let's go ahead and run it here. John has $50.44, there's some extra zeros in his account. So we can even do math with these things. The point is that I'm demonstrating here is that a variable is something you can reference at a later point in time. Okay, we referenced bank balance at a later point in time. We referenced John at a later point in time. Okay, and your program manages all that for you. So we went in depth here. You may not understand it still, but that's all I'm going to cover, because at this point in time, it just takes practice and usage to really understand what's going on here, because you can perform math operations on variables. You can do all kinds of things with them. And that's it for now. That's programming 101 right there. Okay, in a nutshell. So that's it for now. Mark Price at devslopes.com moving forward. And remember, to get your free live help, go to devslopes.com and click on the chat room. We have thousands of students in there helping each other out. Also click on the forums. This is where you can search for answers to your code problems, and you can also post your own issues. So head on over now.